Imagine an incoming enemy warhead entering the exosphere, hurtling toward Earth at over 5,000 kilometers an hour. At that speed and altitude, traditional air defenses are effectively useless. But India can now track that exact trajectory in milliseconds. Before the weapon ever re-enters the atmosphere, a defensive interceptor collides with it head-on, neutralizing the threat in the vacuum of space. That capability officially places India into an exclusive group of nations possessing a functional ballistic missile defense shield. This chart visualizes the global arms import market between 2019 and 2023. Notice this massive slice right here. India accounted for 11% of all international arms purchases, making it the single largest importer on Earth. Depending on foreign suppliers for jets, rifles, and radar systems creates a strategic bottleneck. When a nation shares borders with heavily armed adversaries, relying on external supply lines during a conflict introduces a massive layer of risk. To mitigate this vulnerability, India is pivoting toward Atmanirbhar Bharat, a mandate for the DRDO to build an indigenous, multi-domain technological fortress. This architecture begins at the highest frontier, the exosphere. The military already operates existing systems like the S-400, but those are optimized for lower atmosphere threats like cruise missiles and fighter jets. The recent AD-1 and AD-2 tests occupy a different tier of defense. This diagram shows the logic of ballistic missile defense. You need ground-based swordfish radars that can see thousands of kilometers out. That data feeds into supercomputers to map the weapon's parabolic arc, calculating the exact point where an interceptor can strike it at peak altitude. India is also developing an offensive counterpart. The Dhoni hypersonic glide vehicle is engineered to travel over 10,000 kilometers, skipping across the upper atmosphere at speeds exceeding Mach 5. Maintaining these assets requires an efficient delivery system. ISRO and DRDO recently tested a reusable launch vehicle designed to prevent the loss of expensive rocket boosters and save billions in long-term deployment costs. Controlling this high frontier provides the necessary infrastructure to protect domestic satellites and the launch systems that sustain the nation's multi-billion-dollar space economy. Below the vacuum of space, the focus shifts directly into the atmosphere and down to the ground. The Indian Air Force is upgrading its Su-30 MKI fleet into the Super Sukhoi, centering on the new Virupaksha radar. To make it effective, the entire nose cone is redesigned with composite materials, minimizing signal loss and strengthening electronic warfare capabilities. Further down in the airspace, engineers have developed a new 350-kilogram thrust turbojet engine. This propulsion system is designed to turn standard drones into long-range kamikaze weapons, capable of delivering payloads of up to 1,000 kilograms. Ground-based deterrence relies heavily on assets like the Agni-5 intercontinental ballistic missile. It provides a nuclear-capable strike radius stretching over 5,000 kilometers. But wars are also fought in close quarters. To address urban combat, the military is rolling out hundreds of thousands of newly designed indigenous carbines, specifically tailored for infantrymen in confined environments. Territorial control requires this overlapping superiority, covering everything from Mach-speed fighter jets down to the rifle in a soldier's hands. The final domain of this architecture sits in the critical waters of the Indian Ocean. To secure the coastline from underwater threats, the Navy is deploying a new fleet of anti-submarine warfare shallow watercrafts, including vessels like the Mahay, Arnala, and Androth. Out in deep water, aircraft carrier battle groups require constant early warning of incoming attacks. The current Russian K-31 helicopters are aging, creating a need for a more persistent surveillance net. The solution being tested now utilizes autonomous, electric vertical takeoff and landing aircraft. By launching these AI-driven platforms from the deck, the Navy can cast a wide, distributed sensor net around the entire fleet. Stacking these layers together, space, air, land, and sea, creates one of the most comprehensive defense architectures in the world. Designing a high-tech fortress on a blueprint is an engineering achievement, but manufacturing it flawlessly at scale is a different challenge entirely. Historically, the DRDO has struggled with significant production delays. The Tejas light combat aircraft, for instance, took roughly 40 years to transition from an initial concept to active deployment. The failure of the Kaveri jet engine project to deliver necessary thrust meant the military had to spend billions of dollars on imported American engines just to keep their fighter jets operational. To fix this bureaucratic gridlock, a government committee led by A.P.J. recommended institutional consolidation. The plan merges over 50 scattered research labs into 5 major clusters focused on specific domains like space, AI, and hypersonics. The second reform integrates private sector giants and independent tech startups into the core R&D process. This shift allows the military to leverage the speed and innovation of the private sector to compress production timelines. The scientific talent to build world-class weapons already exists. The final step is restructuring the institutions that manufacture those ideas into a self-reliant future.